All right, final video for the 1-2 notes. If you hear anything in the background, I'm sorry. They're grinding up somebody's brush and trees that they cut down. So I'll try to make this quick so that that doesn't get in the way. Number 5 says, what transformations of the graph f of x equals absolute value of x are applied to the graph to graph the function g? So what things did I need to do in order to graph the function g? So if you remember, up in our last example, a plus sign on the inside meant to go left. So those are the easiest ones. So left 3. And then if I have a number on the very outside, that is a vertical. And then stretch. So a vertical stretch happens when the number out front, so we'll call it A, is greater than 1. And the positive or negative does not matter. So if you want the proper usage there, we're going to say the absolute value of A is greater than 1. So it could be -2, it could be -3, it could be 3. And what that means is it's going to make the graph skinny. But notice this is a fraction. When it is a fraction, it is called compression. And that's when it is between 0 and 1. So again, it could be negative. So like -1/2 is still a vertical compression. The difference is that the negative would make it reflect. And in this case, it does not. So vertical compression of 1/2. So that's all at once. You will see this type of question in every unit all year. So when it says what transformations, it's asking, did it go left, right, up, down, reflect, so forth. Okay. What if you're given the graph and you got to write the equation? Okay, that's taking it up a step. Okay, but you can do it. First, you need to decide, is the picture absolute value or quadratic? There are other types of graphs, if I could talk, sorry, that exist. But for this section, it's either absolute value or quadratic. We're not trying to throw too much at you just yet. Remember, a quadratic is a parabola. Absolute value is the V shape. So this one must be absolute value. So that means that I am going to use this one. All right. To determine what A is, I look at the slope. Over 1, down 1, over 1, down 1, over 1, down 1. So that's just 1. However, it's not going in an up direction. So remember over here, my picture that I drew on top of is an up position. It is down. That means A is -1. All right. My vertex is H and K. So minus -2 and then -4. All we have to do is clean it up. Envision is not going to want you to put 1 there, although it's acceptable in my book. But if you want it counted correct on Envision, they're just going to have a negative out front, no 1. Then, if you recall from when you learned negative numbers, maybe 6th grade, 5th grade, I'm not sure, minus a negative is positive. And then down 4. Here's a way you can check your answer. Type it in here. So negative, whoops, not 2 of them. Absolute value of x plus 4 minus 2. Is that the same picture as your notes? No, because I typed it in wrong. It should be +2 -4. So let me change those numbers. Sorry, that's what I get for trying to do it from memory. There we go. Now, is it the same picture as our notes? Yes, so I did it correctly.